Hi, good morning, everyone, and welcome to the ZP um, webinar on FoodSense. So I will essentially sort of jump straight into it, and basically, let me jump into it, as I say. So I just got to give a quick introduction to ZP. So just bear with me for a second while I do that. I mean, ZP, Zimmer and Peacock, we're the manufacturers and developers of FoodSense. We launched this business in 2014. We're what they call ISO 13485. So this means that we're kind of qualified for the development and manufacture of electrochemical biosensors and IVDs. So we will be obviously talking about FoodSense and the testing of chilies shortly, but let me just go forward a little bit with this at the moment. We are, as I say, contract developers and manufacturers of biosensors. Our biggest facility is sort of 4,000 square meters. So on some scales, that's quite big. On other scales, it's quite small. And we're primarily based in Norway and in the UK. So we've been around now for approximately 9 years. We're certified for really making medical products, which means that we're extremely qualified for making these sort of food testing products. We have quite big facilities. We are international in our outreach. This is the team itself behind the FoodSense. And as I say, we've got multiple sites across the globe where we do R&D and we do development and manufacturing. We're really part of what we call Industry 4.0. So Industry 4.0 really is people talk about the Internet of Things, where you measure and things are connected and things control each other. And Industry 4.0 is an extension of the Internet of Things. And really, it's about measuring, how would I say it, measuring parameters. So FoodSense is, a small device, and you will see a live demonstration of this small device very shortly. And we use it to measure things like chili sauces. We use it to measure chili powders, chilies as well. So as long as we can get the kind of product into the liquid phase, then we can test it, essentially. The background to this technology is, it was about 15 years ago, a professor at Oxford University called Professor Richard Compton. He released a paper, and in that paper, he described a kind of an electrochemical rapid way of detecting capsaicin in these products. And I'm sure many of you know, you're attending because you've got some interest in chilies and chili products and measuring their hotness. So you'll know this molecule capsaicin. But what Richard did in that original paper was he used an electrochemical technique called cyclovoltammetry to actually measure the, first of all, is capsaicin present, which you can actually obviously determine by tasting, and if it's present, how much of it is actually there. So that paper was sort of very intriguing to us at ZP, and it also got a lot of international coverage around the world, which kind of told us that there was this, sort of big interest in the market, let's say, for measuring capsaicin. So, as I say, originally this was came from Oxford, and in the original Oxford paper, they were sort of saying, look, if you want to measure the hotness, the Scoville heat unit of a chili product, you can use an analytical technique, and HPLC is, high pressure liquid chromatography is a way of measuring organic compounds. So capsaicin is obviously an organic compound, and HPLC is a way of doing it. The problem with HPLC obviously is it can be something, at least a $50,000 instrument. You do need organic solvents. You do need to maintain that particular instrument. And you often need, quite qualified chemists in order to run that analytical equipment. So HPLC is perfectly fine. The sample preparation is extremely long. And I'll also mention in a bit that HPLC is not the golden standard that people necessarily think it is. Obviously, the other way of determining the hotness, the Scoville heat unit of a product, is to do a panel testing. this is what Wilbur Scoville, I think the paper, the original paper, which talks about Scoville heat units, I think it was published in 19, and I can't remember if it was the 30s or 1912 or 1936 or something early 20th century. And in there, he describes the idea that you taste something and you keep on diluting it till you can no longer taste it. So that was this kind of Scoville not oligomer, but oleptic testing, organoleptic testing. And there's also guessing. And so what I mean by guessing is, people essentially are just tasting it and using their quality manager to sort of determine whether the product is within spec or not. I think there's a lot of guessing going on. And then there's fourthly, obviously, FoodSense, which is what we'll describe today. So FoodSense, rather than being a subjective kind of organoleptic testing, is an objective test where we're making a analytical science measurement upon the sample. And we'll do, as I say, I think we're going to do about 3 demos today, at least 2, but maybe 3 demos today. We want to keep this webinar nice and compact, so because we know that everyone's, a lot of people are in industry, they're very busy people, so we want to be respectful of your time. But this is an objective measurement rather than a subjective measurement. What I mean is you get essentially a number as opposed to just a feeling on the tongue. I did mention that Zimmer and Peacock, we are ISO 13485, so we're perfectly qualified to make medical products. And actually the sort of history of this company is really in glucose strip manufacturing. So when you look at a glucose strip for testing the bloods of diabetics, you'll notice some strong similarities between this and the FoodSense. So, we have a meter, we have essentially sensors, and we also have apps, and you'll see the app used today by my colleagues. As I mentioned earlier on, HPLC is one way of determining the Scoville heat units of chili powders, chili products, but it's people use it, but they don't overuse it. And I think it's primarily because owning an HPLC is extremely expensive. The upkeep of an HPLC is extremely difficult. So it's easier just to kind of take a sample and send it to the lab and get the lab to test it. Of course, this means that, it can be something like 100, depending where you are in the world, $100 to get that test done. And in a market where it's extremely competitive and margins are very low, we can understand that's actually not particularly competitive. But anyway, in developing our system, we actually did compare against the HPLC to make sure that we were kind of correlated with the HPLC results. So that was that was part of the validation of this technology. Since we first did that validation, we launched the Generation 1 product. It was actually a academic. He was actually at the University of Minnesota, but he was working with Purdue University in the USA. A gentleman called Charlie Rower. This was unbeknownst to us, but they actually ended up purchasing one of the early generations of the FoodSense, and they actually ended up independently validating this. And so there is an academic paper out there. Now, I know it's hard for you guys because, but there is a kind of URL here, a link here to that original paper, which Charlie did. And the reason I bring it up is because we did our own validation versus HPLC to make sure that we were correlated. But then actually an academic group just independently of us also did their own validation, and they speak quite highly of the FoodSense in that paper. And the reason being is A, it correlates, B, they were able to run every sample in triplicate, and when they compared it against HPLC, they were only able to run one test on HPLC per sample because in fact it was so expensive to do. They couldn't afford to do multiple testing. So I think they really liked the fact that they could get a quick result and confirm it by doing 3 tests at a time especially because when you're dealing with chilies, chili powders, chili sauces, these are what we call very heterogeneous samples. And what I mean by heterogeneous samples is, a chili powder can have a distribution of hotness throughout it. It's not just, it's not just all the chili and all the powder has a uniform Scoville heat unit. In order to really understand, a sauce or a powder or a chili, you may have to actually sample it several times and essentially get the average of it, which then the FoodSense allows you to do because it's pretty rapid, low cost, and you can just do it there and then. Whereas if you wanted to do that with HPLC, it can be quite an expensive process. So anyway, there's an independent paper out there which we've referenced to. One of the things I just want to kind of comment upon is that for us, the FoodSense actually offers high accuracy and high precision. And by high accuracy and high precision, if the truth of the Scoville heat unit of a product is the kind of bullseye here, we can get in with some good accuracy and some good precision. So if you did it in triplicate, you would end up with a sort of repeatable result. The reason I bring this up is because people really think, and it's not to criticize, but that, HPLC is this kind of wonder technique, and that you send the sample off, you get your certificate of analysis back, it has a measurement on it in Scoville heat units, and, therefore, that is the truth. What you notice actually when you're looking at these certificates of analysis from HPLC, that there's very rarely any kind of error bars on it. So it's almost like you're getting an absolute result, but actually there's no error associated with it, because with every measurement in life, there's always, let's say an error, plus or minus 5%, plus or minus 10%. But people really believe these certificates of analysis, but actually, if you don't report an error, then you're kind of, the error could be plus or minus 50%, for example, but you just essentially don't know. So at Zimmer and Peacock, we do obviously, aim for high accuracy and high precision. But what we do notice a lot of the time is that people will come with certificates of analysis from HPLC and say, this is our truth, let's say. But it's not actually always the truth that they think it is. So the scenarios that we've come across is that you can send the same sample to different labs, and each lab will give you a certificate of analysis, but you'll actually find out that the Scoville heat unit reported each time is actually different. And I think, we've got billion-dollar businesses that are doing this, and they know this fact. In the smaller companies, they don't actually realize that this is actually what's going on. Another test that we've seen people do as well is they will take the same sample and send it repeatable times to the same laboratory. Now, and the laboratory will actually end up giving them, it's important not to send these samples all at the same time, because what you want to do is send them sort of 1 week, then the next week, and then the next week, and you'll end up finding out that the results could be quite different. So the reason I sort of segue off to HPLC a little bit is because there is no real comparison between FoodSense and HPLC, and what I mean by that is we correlate well with them. Much lower cost, much faster, don't require organic solvents, don't require columns, don't require a laboratory, don't require trained personnel. So it's just a very different cost and user experience. Now I have promised you a demo, and I will that will happen shortly, but it's fair to say that we're actually something on like generation 3 now of FoodSense. So this is not a product that's just arrived on the market. This has been out there for a few years. And as I say, we're on sort of Gen 3 at this stage. Something that I want to just, this webinar is to introduce FoodSense, give you a sense of the current state of testing, which is, organoleptic testing, which is tasting, HPLC, FoodSense. And also one of the other technical aspects I want to cover here is actually the solubility of capsaicin. I will discuss why we're covering the solubility of capsaicin very briefly, but I just want to say that capsaicin, the molecule that gives you this sensation of heat, is a poorly soluble molecule. And what I mean by that is it doesn't just dissolve into, if you made like a sort of vinegar, a water plus vinegar mixture, capsaicin doesn't just dissolve into that. It's actually got about a range of solubility in about 13 ppm to 29 ppm. So ppm means parts per million. What that means is that if you try to dissolve capsaicin into liquid, the solubility range is about 208 Scoville units to 435 Scoville units. Now, I know these are very low numbers because You know, Tabasco has a Scoville heat unit, Tabasco sauce that is, of 2,500. The bomb has a Scoville heat unit of about 125,000 Scoville heat units. But I'm just saying that capsaicin intrinsically is actually not that soluble. What makes it soluble is all the fats and oils. These are sort of essentially organic materials that help to dissolve the capsaicin and help it dissolve into the sort of primarily aqueous system. Now, the reason I mention this is because what you'll notice today is if we think, so the advantage of FoodSense is this: you can take a sauce, or you can take a powder, you can take a chili, you can prepare the sample, we'll put it into an extraction solution, we'll put that straight on the sensor, we get a result, great. But you'll notice that we change the volume if we think the sample is hotter. The reason we do that is because capsaicin is not terribly soluble. You need organic solvents like ethanol and things, materials that are quite organic in nature in order to dissolve it. But we don't want to do that because now you're getting into a sort of laboratory setting, and you can't really have these organic chemicals necessarily so close to food production. Some of them are definitely toxic. So what you'll find out is that if we think the product is mild, we might suggest what we call a 1 in 10 dilution. That's because we know that it's quite mild. It only has a certain amount of capsaicin in it. Therefore, just take 1 volume of the sauce and put it in 10 volumes of our buffer, and that'll be enough to dissolve all the capsaicin. If we think it's hotter, and when then a chili powder, for example, I'm making this up now, but 100,000 Scoville heat units, we will dissolve it in a larger volume of buffer because we know that we have to dissolve all this capsaicin. So then you'll see us talking about dissolving it 1 in 100 volumes or 1 in 500. So when you see that happen, it's because capsaicin is fundamentally not terribly soluble. How do we overcome that? We increase the solution that we dissolve in. But the app that you'll see my colleague Sol run in a minute, as long as you put this ratio in there, it just back calculates what the original Scoville heat units were. So it's not a piece of maths that you have to do yourself. It's actually done straight away in the app itself. So in a minute, we're going to do a demonstration. We're approximately going to do 3 samples. We only do Tabasco sauce because it's sort of something that it's almost a tradition for us. But we will do Tabasco, we'll do something called Naga, and we'll also do a chili powder as well. So what I'll do is I'll stop sharing my screen, but it will then change over to my colleague Solrun, and Solrun will do a live demonstration for you as well. Thanks, Solrun.
All right, so as Martin said, my name is Solrun, and I'm a scientist here at Summer Peacock, and I will run a quick demonstration for you. So first, I want to show you the sensors that Martin was talking about. This is the flexible chili sensor. It's quite tiny, and what we will do is we'll insert it into the FoodSense box. And the FoodSense box fits in my hand, and you have an opening here that we will insert the sensor. So so I've inserted the sensor into the FoodSense box, and now I will prepare the sample. So we have the Tabasco sauce for this, and I'll just shake it a bit just so that to make sure that the solution is as homogeneous as possible. And I will add some of the Tabasco into a weighing sheet just so that it's easier for me to pipette it out of the bottle like that. And as Martin said, Tabasco is not that spicy. It doesn't have that much capsaicin, so we will be using a 1 to 10 ratio. So I will add 1 milliliter of the chili pulp fluffer. Okay, I'm adding 1 milliliter of the chili pop buffer into the vial. And then I'm adding 100 microliters of the Tabasco sauce in this in the chili pop buffer. And we're using a vortex for the simplicity of mixing the solution together. As you can see here, it's now separated, and I'll just use the vortex. And the advantage with Tabasco is that Tabasco is quite homogeneous. It doesn't have a lot of chunks and bits, so I don't need to mix it for a long time. It mixes quite easily. So now you can see after just mixing it for 15 seconds, it looks quite fairly homogeneous, but it's still got some chunks and bits, but that's okay. We'll just pipette it onto the sensor. But the capsaicin in itself, we believe that is extracted from the chunks and bits from the sauce into the solution. So what I will do now is I'll pipette 50 microliters of the solution onto the sensor. And I'm careful not to scratch the surface of the sensor, so I don't scratch the electrodes or anything. And I will try to show you what it then looks like. You see here that it got like a bubble that is covering the electrodes of the sensor. So make sure to cover all the electrodes. Okay. All right. And then here is the app of the FoodSense app, and it's connected to the FoodSense box. And as you can see, the mixture ratio is 1:10. So I'll click measure, and it will use a short minutes, and it's going through a cyclical tomogram, and it's using the peak heights to determine just how much capsaicin we have in the sample.
Yeah, and so earlier on when I was discussing the original work from the Compton group in the University of Oxford, they had a very sort of scientific paper, as you could appreciate. It was full of sort of, electrochemistry and discussion about, cyclovoltammetry and all these kind of techniques. And of course, we understood that is not going to translate super well, if I could put it that way, into a product that could be used in the food sensing world. So, our job at Zimmer and Peacock was to sort of take our experiences of turning science essentially into products and saying, okay, this is not going to be a good experience for the food technologists. So what should we do? So we basically had to kind of take that workflow and convert it into an app. And so the app, what the app is doing now is we've put the sample on the sensor as Solrun indicated, and the app Solrun told it this is what the dilution was, and so she told them, I did a sort of 1 in, I think it's approximately 1 in 10 dilution, and then the app essentially tells the meter what to do, and the meter then progresses around. The meter then sort of goes through the technology and comes back with a result. Now, one of the questions that I've just seen somewhere, the question just flicked up. It just then told me, it said, is the sensor a single use or a multiple use? So unfortunately, this is just the way it is. Because you've just put capsaicin onto that sensor. The first thing is that you've essentially, you get a result, but what happens is, I don't want to use the word contaminated, but now you've put a sample on it. So the first problem that you would face is if you try to reuse the sensor, you have to have a cleaning routine that guarantees that all of that capsaicin, all of that sample is actually coming off the sensor. Now, so you could think, oh, okay, well, I'll invent a method. I'll invent a method that cleans the sensor. But there's actually a fundamental problem here that capsaicin binds to these sensors in a, how do I put it, a sort of irreversible manner. And it's just not going to come off. So it doesn't matter how much cleaning you do, that capsaicin is stuck to that sensor. So if you try to run that sensor again, you're just going to get a higher result. So you can try this for yourselves, but if you've got one of our sensors and you make a measurement, you get a result. So in this case, Solrun's measured the Tabasco at 5,146 Scoville units. But if I'm not going to get it to do this, but if you did it again, you're going to get something like 6,000 because it's sticking to the electrode. So the short answer to your question is no, you can't reuse sensors. They're one-time use. First of all, it's good practice because otherwise you're going to have to clean the sensor. And secondly, in this case, you can't actually clean the electrodes. The capsaicin is an organic molecule that loves to stick to the sensors. And if you reuse them, you just get higher and higher results. Sorry, Solrun, I know you're having a thing about screen sharing there. So the score for the Scoville heat units for Tabasco sauce, what was that from memory?
That was 5,000.
5,000. Somebody just asked us why no run. What they mean is why you weren't showing it in real time. And I think basically the software that was allowing Solrun to share her screen froze. So she had to reboot the screen sharing software. So what we should do, Solrun, is we run Tabasco, run them another sample now, and we'll essentially do it again. So everyone watch again, and we'll do it again. But we're going to do a different sample type. So I'll shut up, Solrun, and you carry on.
Yeah, no worries. I'll run a new measurement. I saw everything in real time, so I know this a bit late that it didn't show on screen. So sorry about that. But now I will prepare a sample with pure Naga, which is just a chili paste. And it's a lot more chunky than the Tabasco sauce was. So again, I will put some in a weighing strip just so that it's easier for me to pipette. And then I expect the pure Naga to be a lot more spicy. It has a lot more capsaicin than the Tabasco sauce. So this time I will be using a 1:100 ratio. And in order to do that, I will mix it with 5 milliliters of the chili pop buffer and 50 microliters of the pure Naga. So I will use the pipettes.
And so just to emphasize earlier on, the reason you didn't see the app running in real time is Solrun is sharing her screen basically with this. We're sharing the screen off that smart device, and the screen sharing software crashed. But hopefully this time you'll be able to see the app running in real time.
So 5 milliliters of the chili pop buffer, and now I'm pipetting at 50 microliters of the Naga sauce, like that, and I will just mix it into the buffer. I will show you what it currently looks like that, and then I will quickly use the vortex. And since this sauce is more chunky, like if you look at the Tabasco, it's quite works as a liquid, while as for the Naga sauce, it's much more chunky. So that also means that we need to give it a little bit more time on the vortex just to mix and to extract that capsaicin from the sample. And also, if you have a sample that is really chunky, like for instance, if you cut up chilies and want to mix that with a buffer, ideally you might even allow it to sit on the bench for an hour just to give it the time to extract the capsaicin from the chunks and bits. But with more homogeneous solutions, it's easier to mix it right away. And now you see that it's fairly homogeneous. There's still some like cloudy chunks, and that's all right. We just pipette it onto the sensor, and that will be fine. So again, I will pipette 50 microliters onto the sensor. 50 microliters is a volume that will cover all the electrodes of the sensor. So I'll pipette it onto the sensor like that. And then I will click measure, and now it will run for a short minute. And as you can see now, you see the bar, the circle bar that is working through the progress. And what it's doing is running through those two cyclical tomograms and seeing whether looking at the heights of the peak of the tomograms. That's the scientific approach of this method.
And what makes this work really well is because we've actually got very repeatable sensors. Otherwise, this would not work. So we do a lot of good calibration in our factory. But here we come to the end. What did we get, Solron?
14,000 is
what
we got for this sample. So as you can see, it's more spicy than the Tabasco for sure. And lastly, I want to show a powder. So this is a chili powder, and what we would do, I will replace the sensor because, as Martin said, these sensors are one-time use sensors because the capsaicin as we enter every time. So I will add a new measurement, and so what I will do, I will again use the mixture ratio 1:100, and I have already weighted out 0.1 gram using a small weight like this. So 0.1 gram, and then I will add 10 milliliters of buffer into this. But I also I cheated and I prepared this solution yesterday just to give it the time to extract the capsaicin from the powder itself. So you see here that the powder is falling to the bottom, but still the capsaicin is extracted into the solution. So I will just give it a quick mix, just for the solution to be mixed well, and then again the powder will fall to the bottom, but I will just pipette the solution on top, and that should be a homogeneous solution with an evenly distributed capsaicin concentration. So again, I will pipette 50 microliters onto the sensor like this. Like that, and then I will click measure on that, and I will let it run. And yeah, so the sample preparation is definitely a crucial step when it comes to chili sensing, and it's just because we need to get access to that capsaicin, which you find in the different salsas or powders or the raw chilies themselves. So we just need to be patient and just try to mash up the chilies if that's what we want to measure, and just give it the time to get into the solution. And now it's soon wrapping up. And here you see that the result is 100,000 Scoville heat units. So the powder is quite concentrated with capsaicin. So now you've seen you've seen a range of 5,000 with the Tabasco to 12,000 was it with the naga puree to 100,000 for the chili powder. So it goes over a wide range. And then yeah, you can also look at your results in the app and look at your former results. So yeah,
Brilliant.
thank you. And
thank you, Solron. I appreciate that. So that was essentially 3 demos, and it's quite nice because you did, as you say, you went from 5,000. The Naga was actually 14, if I remember rightly. But the video, we'll put the video up on YouTube later on, so people can kind of catch it later on. And then that chili powder was about 100,000. What's really nice about the technology at ZP is we see these raw signals, so we don't just get a number. We see the raw signals, so we're able to actually prove our point on occasions, because people say, oh no, it's hotter or it's not. It's like no, these we can literally see the molecule. So let me just make a few last comments. So today we just gave a quick introduction to the business. We're ISO 13485. We're an international team. Our biggest facility is 4,000 square meters. And we've been manufacturing this product now. We're on about generation 3. We've been doing this, I would say, for over 5 years, but it's a technology that originally came from the University of Oxford, a gentleman called Richard Compton, and Professor Richard Compton, and we've obviously productized it. And then we've essentially said that, look, this is an objective way of doing it, and it's a very good, I would say, viable alternative to HPLC. Now, I want to highlight that if you want to see this demo or webinar again, we will put the we've recorded today. We'll get the videos onto YouTube. But I also want to say that on the 22nd of June, we're going to do this today, and we're going to do the same demonstration again. So if you've got colleagues that you would like to see this, and they want to see it live, and they can ask their questions. We had a couple of questions come through today. One of them was about, can we reuse sensors? The quick answer is unfortunately not, because the capsaicin sticks to the electrodes. And then the second question was whether why did they not see it live? And it was just a bit of software issue, but we obviously on the second and third run, Solron was able to fix that problem. So if you're got any questions or for Zimmer Peacock, don't hesitate to reach out to us at FoodSense. And we are going to do this webinar again on the 22nd of June 2023. So at this point, I want to thank everyone for coming to our webinar today. We put aside 45 minutes. We want to be respectful of your time. But as I say, I might just share the website with you for a second, just to show you where you can contact Zimmer Peacock if you do have any questions. So this is the ZP FoodSense website. There's a contact page here, and that will direct you to a form, and you can fill that out. And somebody asked us today to send them some information, and they had it within about an hour. So please don't hesitate to reach out to us. And if you have any questions, also reach out to us and ask us there. Otherwise, I wish you all a good day, and thank you very much.